Hi, in this video we will learn about equations of motion. So before writing down all the equations, we need to make some simplifications. Instead of writing delta t, we write only t. So each time you see t, it means the whole time that event is happening. We say delta t is equal to final time minus initial time. And to make it easier, we usually set our time from 0. And so this is equal to 0 usually. So delta t is equal to final time that the stopwatch is showing. And we show that with only t. Delta x, we show it with x minus x sub 0. So x here is final position. We say delta x is equal to x f minus x 0. This one is final position. This one is initial position. So we don't write f anymore. We just write x. So x is standing for final position. Delta v is equal to v minus v sub 0. V, we don't write f anymore. We just write v. Because we said delta v is equal to final velocity minus initial velocity, v sub f minus v sub 0. But from now on, we just write v. V is standing for final velocity. A bar is standing for average acceleration because acceleration is constant, so average acceleration is equal to acceleration at any time is equal to instantaneous acceleration. So we don't need to write bar anymore. We just write A, and A is standing for average acceleration. But for velocity, we write the bar average velocity. This is average velocity. If there is no bar like this, that will be final velocity. And v sub 0 is initial velocity. So let's get started. We know average velocity is delta x over delta t. This bar means average. Average velocity is delta x over delta t. Delta x is final position minus initial position over delta t. We said we just write t, and I didn't write x sub f. I just wrote x. This x is final position. And then v times t is equal to x minus x sub 0. So x is equal to vt plus x 0. This is the common equation between motion with acceleration and uniform motion. When acceleration is constant, average velocity is equal to initial velocity plus final velocity divided by 2. Initial, final velocity divided by 2. And we know that acceleration is equal to delta v over delta t. Again, final velocity v minus initial velocity v0 over t. So v minus v sub 0 is equal to at. V is equal to at plus v sub 0. Another equation for constant acceleration. So we know v is equal to v0 plus at. If we add v sub 0 both sides, then we have v plus v sub 0 is equal to v sub 0 plus v sub 0 plus at. Then divide both sides by 2. We have v plus v0 over 2 is equal to these two will be cancelled. V sub 0 plus 1 over 2 at. And this is v bar is average velocity. So average velocity is equal to v0 plus 1 over 2 at, and v bar is delta x over t. So delta x over t is equal to v0 plus 1 over 2 at, and delta x is x minus x0 over t is equal to v0 plus 1 over 2 at. So multiply both sides by t. X minus x0 is equal to v0 t plus 1 over 2 at square. Moving x0 to the right side, x is equal to v sub 0 t plus 1 over 2 at square plus x sub 0. So final position is equal to this. So we said acceleration is delta v over t, which is equal to v minus v0 over t. So t is equal to v minus v sub 0 over a. And since average velocity is v sub 0 plus v over 2, and this is x, then if we combine all of them, then v squared is equal to v sub 0 plus 2a x minus x sub 0. And here are the summary of all the equations we learned. So x is final position, x sub 0 is initial position, v bar is average velocity, t is time, v bar is average velocity, v sub 0 is initial velocity, v is final velocity, v is final velocity, v sub 0 is initial velocity, a is acceleration, and t is time. X is final position, initial velocity, time, acceleration, time, final velocity, initial velocity, acceleration, final position, initial position.